everyone, my name is Giancarlo Villadorino.
Hi, my name is Gian Paulo Resuena.
My name is Gian Crisi Alegre.
Data preprocessing. What is data preprocessing? Cleaning, integration, reduction, transformation, discretization.
So what is data preprocessing? Data preprocessing is the process of transforming raw data into understandable format. It is also an important step in data mining as we cannot work with raw data. The quality of the data should be checked before applying machine learning or data mining algorithms. So data preprocessing is a component of data preparation. It describes any data of processing performed on raw data to prepare it for another data processing procedure. It is a data mining technique that transforms raw data into an understandable format, or real-world data is always incomplete and that data cannot be sent through a model. That is why we need to pre-process data before sending through a model.
Cleaning. Data cleaning. Data cleaning is the process of preparing raw data for analysis by removing bad data, organizing the raw data, and filling in the null values. Ultimately, cleaning data prepares the data for the process of data mining, when the most valuable information can be pulled from the data sets. Yun po. Based nga dun sa definition ng data cleaning is that yung mga raw data na gagamitin para sa analysis ay nililinis muna sa pamamagitan ng pagtatanggal ng mga bad data, then ino-organize, at kung may mga data na walang laman, need itong lagyan ng laman. Dahil nga ginagamit natin itong data cleaning technique para makakuha tayo ng mga best value of information or mga quality ng data para sa pagdi-data mining. Dahil kapag magandang data ang nakuha natin, mas magandang decision making ang magagawa natin.
The data can have many irrelevant and missing parts. To handle this part, data cleaning is done. It involves handling of missing data, noisy data, etc. Missing data. This situation arises when some data is missing in the data. It can be handled in various ways. Some of them are: Number 1. Ignore the tuples. This approach is suitable only when the dataset we have is quite large and multiple values are missing within a tuple. So, ang ignore the tuples is nakadepende sa large set of data, which means kapag hindi ganun kadami ang missing values in several attributes in tuple, is hindi ito effective.
Fill the missing value. There are various ways to do this task. You can choose to fill the missing values manually by attribute mean or the most probable value. For example, by simply dropping rows or columns with missing data. If the missing data is not valuable, just drop it. Just drop it from your analysis.
Noisy data. Noisy data is a meaningless data that can be interpreted by machines. Can be generated due to faulty data collection, data entry errors, etc. So, noisy data is yung mga data na hindi makakatulong na sinasabi nga sa definition na it can't be interpreted by machines. So, meaning na hindi tama yung mga laman ng data na kung saan masasabi nating meaningless data. At makukuha daw ito due to faulty data collection, data entry errors, at iba pa. And in this case, it can be handled in following ways.
Binning method. This method works on sorted data in order to smooth it. The whole data is divided into segments or equal size, and then various methods are performed to complete the task. Each segmented is handled separately. One can replace all data in a segment by its mean or boundary values can be used to complete the task. Binning method is nagre-reduce ng effect ng minor observation errors. Binning is like categorizing the data or dividing the data into segments para mas ma-organize ang data, and most importantly is para hindi mawala ang data.
Regression. Here, data can be made smooth by fitting it to a regression function. The regression used may be linear by simply having one independent variable or having multiple independent variables. Regression is a data mining technique used to predict range of numeric values or also called continuous values given a particular dataset. For example, regression might be used to predict the cost of a product or service given other variables. A regression model determines a relationship between an independent variable and a dependent variable by providing a function. Another example is we can say that age and height can be described using a linear regression model. Since a person's height increases as its age increases, they have a linear relationship.
Clustering. This approach groups the similar data in a cluster. The outliers may be undetected or it will fall outside the clusters. Clustering for handling noisy data. Dito sa clustering, sabi, approach groups the similar data in a cluster, so meaning pinagsasama-sama niya yung mga data into a group, yung mga similar data or similar objects. At yun, ito yung pinaka-aim ng clustering, to segregate groups with similar traits and assign them into a cluster. So magiging organized na ngayon yung mga data which can help to improve na makakuha ng good quality of data.
Integration. Data integration is a data pre-processing technique that involves combining data from multiple heterogeneous data sources into a coherent data store and provide a unified view of the data. These sources may include multiple data cubes, databases, or flat file. The data integration approaches are formally defined as triple GSM, where G stands for the global schema, S stands for heterogeneous source of schema, and M stands for mapping between the queries of source and global schema. Ang integration is combining the data from different sources. Ginagamit din ito sa data warehouse, at it is very important for the data. Making a whole or unified data is easier to handle it.
Two major approaches for data integration. First is tight coupling. Here, a data warehouse is treated as an information retrieve component. In this coupling, data is combined from different sources into single physical location through the process of ETL, or also known as extraction, transformation, and loading. We can say that tight coupling is a technique in which hardware and software components are highly dependent on each other. It is used to refer to the state or intent of interconnectivity between two or more computing instances in an integrated system.
Loose coupling. Here, an interface is provided that takes the query from the user, transform it in a way that the source database can understand, and then sends the query directly to the source databases to obtain the result, and the data only remains in the actual source databases. So dito naman sa loose coupling, one of the major approaches for data integration is that it provides an interface para makakuha ng query galing sa user na kung saan yung source ng database is maiintindihan at makukuha yung result ng query ng user. At kung ano lang yung ginustong makuha ng user is yun lang ang makukuha niya.
Issues in data integration. There are no issues to consider during data integration. Schema integration, redundancy, detection, and resolution of data values conflicts. These are explained in brief below. Number 1. Schema integration. Integrate metadata from different sources. The real-world entities from multiple sources are much referred to as the entity identification problem. So, this integration is ginagamit in combining the database schemas into a single schema. It is so important dahil you can store a data from the two original databases using the combined database. Schema integration is also useful in large databases.
Next is redundancy. Redundancy is an attribute may be redundant if it can be derived or obtaining from another attribute or set of attributes. It is also inconsistencies in attributes can also cause redundancies in the resulting dataset. Some redundancies can be detected by correlation analysis. Redundancy from the word itself, it is something that is repeated unnecessarily or something that is not useful because there is already another or more advanced version. An example of redundancy is when a piece of text says the same exact thing twice.
3. Detection and resolution of data value conflicts. This is the third important issue in data integration. Attribute values from different sources may differ for the same real-world entity. An attribute in one system may be recorded at a lower level abstraction than the same attribute in another. So, yun. The third important issue in data integration. Dito sa issue na ito, attributes values from different sources may differ for the real world entity. Which is in this case, possible na itong mga values na ito ay hindi naman makakatulong dahil nga it is differ for the real world entity. And isa pa is may mga attribute na marirecord at a lower level abstraction that the same attribute in another.
Reduction. Since data mining is a technique that is used to handle huge amount of data while working with huge volume of data, analysis became harder in such cases. In order to get rid of this, we use this data reduction technique. It aims to increase the storage efficiency and reduce data storage and analysis cost. The various steps to data reduction are: So, reduction, from its word, meaning nagre-reduce siya ng volume ng data storage, and analysis cost. It is helpful in data mining because data mining is using a large amount of data that are not easy to handle.
Data cube aggregation. It is an aggregation operation being applied to data for the construction of the data cube.
Attribute subset selection. The highly relevant attributes should be used. Rest all can be discarded. For performing attribute selection, one can use level of significance and p-value of the attribute. The attribute having p-value greater than significance level can be discarded. So, one of data reduction step is attribute subset selection. At dito sa step na ito, ang highly relevant o mga kailangan lang na mga attribute ang dapat gamitin. Ito yung iba pa ay hindi na pwedeng gamitin. Which is a good way of reducing data. Kasi mas pinaprioritize natin yung mga mas mahalaga na data dahil yun ang mas makakatulong sa isang organisasyon kaysa sa gamitin ang lahat ng data.
Numerosity reduction. This enables to store the model of data instead of whole data. For example, regression models. So, ang numerous reduction is also reducing rin ng data in a way na nire-replace niya ang original data by smaller form of data.
Dimensionality reduction. This reduces the size of data by encoding mechanisms. It can be lossy or lossless. After reconstruction from compressed data, original data can be retrieved. Such reduction are called lossless reduction, else it is called lossy reduction. The two effective methods of dimensionality reduction are wavelet transforms and PCA, or also known as principal component analysis. So dimensionality reduction is the transformation of data from a high dimensional space into a low dimensional space so that the low dimensional presentation retains some meaningful properties of the original data, ideally close to its intrinsic dimension.
Transformation. Data transformation in data mining. The data are transformed in a ways that are ideal for mining the data. The data transformation involves steps that are: first, smoothing. It is a process that is used to remove the noise from the dataset. Using some algorithms, it allows for highlighting important features present in the dataset. It helps in predicting the patterns. When collecting data, it can be manipulated to eliminate or reduce any variance or any other noise form. The concept behind the data smoothing is that it will be able to identify simple changes to help predict different trends and patterns. This serves as a help to analysts or traders who need to look at a lot of data, which can often be difficult to digest for finding patterns that they wouldn't see otherwise. So one step of data transformation is the smoothing. At dito sa step na ito, kung saan nire-remove yung mga noise data na gumagamit ng mga different algorithms, sa pamagitan nito, na-highlight yung mga importanteng features na meron sa isang dataset. At dito, mas nakakatulong in predicting patterns at talagang nakakatulong ito sa mga data analysts. Nakakatulong talaga ito smoothing lalo na sa mga kailangan pa humanap ng at tumingin ng maraming data para lang makahanap ng pattern.
Number 2. Aggregation. Data collection or aggregation is the method of storing and presenting data in a summary format. The data may be obtained from multiple data sources to integrate these data sources into a data analysis description. This is a crucial step since the accuracy of data analysis insights is highly dependent on the quantity and quality of the data used. Gathering accurate data of high quality and large enough quantity is necessary to produce relevant results. The collection of data is useful for everything from decisions concerning financing or business strategy of the product, pricing, operations, and marketing strategies. For example, sales data may be aggregated to compute monthly and annual total amounts. Ang aggregation is like a integration. So, ang aggregation is nagsasummarize ng data. It is very useful sa data mining because using aggregation, which summarize the data like sales, helps to see the different sale in the past and the present. It is also helpful in business to see if their strategies or product are effective or not. It is also help the business to make a decision in changing their strategy if their sales is low than before.
Number 3 is discretization. Discretization is a process of transforming continuous data into set of small intervals. Most data mining activities in the real world require continuous attributes, yet many of the existing data mining frameworks are unable to handle these attributes. Also, even if a data mining task can manage continuous attribute, it can significantly improve its efficiency by replacing a constant quality attribute with its discrete values. For example, counting from 1 to 10 and 11 to 20. Another example is age, such as young, middle age, and senior.
4. Attribute construction. Where new attributes are created and applied to assist the mining process from the given set of attributes. This simplifies the original data and makes the mining more efficient. So for example, categorical attributes such as house addresses may be generalized to higher level definitions such as town or country. Dito naman sa attribute construction na kung saan may mga set of attributes na pwedeng pagsama-samahin at makagawa ng bagong attributes. So, sabi nga na this simplifies the original data and makes the mining more efficient. At yun nga, kung titingnan natin sa example like categorical attributes tulad ng house address, pwede nang i-generalize to higher level definition tulad ng town o country.
Number 5. Generalization. It converts low-level data attributes to high-level data attributes using concept hierarchy. For example, age initially in numerical form, 22-25, is converted into categorical value, young, and old. For example, categorical attributes such as house addresses may be generalized to higher level definitions such as town or country.
Lastly is normalization. Data normalization involves converting all data variable into given range. Techniques that are used for normalization are min-max normalization. This transforms the original data linearly. Suppose that min A is the minima and max A is the maxima of an attribute P, where V is the value you want to plot in the new range and V is the new value you get after normalizing the old value.
Data discretization. It is a process of transforming continuous data into a set of small intervals. Most data mining activities in the real world required continuous attributes. Yet, many of the existing data mining frameworks are unable to handle these attributes. Also, even if a data mining task can manage a continuous attribute, it can significantly improve its efficiency by replacing a constant quality attribute with its discrete values. For example, 1 to 10, 11 to 20. Age, young, middle-aged, senior. Data discretization ay yung process ng pagtatransform ng continuous data into a set of small intervals. So ang sample continuous data is temperature na kung saan may mga number range. So at this kind of attributes ay mahirap i-handle in terms of data mining. At yun nga na kahit na kaya namang ma-manage ang gantong kind of attributes, mas efficient pa rin yung re-replace nitong attribute ng kanilang discrete values. Yun yung example is, instead of using range in age which is 1 to 10 or 11 to 20, mas efficient yung paggamit ng discrete values nila which is young, middle, age, senior, which is technically may range pa rin sila pero mas madali nang ma-distinguish o mas madali na ma-interpret ang ganitong values. Discretization is typically used as a pre-processing step for machine learning algorithms that handle only discrete data. Data discretization is defined as a process of converting continuous data attribute value into a finite set of intervals with minimal loss of information. Mathematical problems with continuous data have an infinite number of DOF. Such a problem would entail having limited degrees of freedom or DOF since our calculations cannot go on forever. Data scientists require using discretization for a number of reasons. And yun, typically ginagamit daw ang discretization na kung saan may mga machine learning algorithms na discrete data lang ang pwedeng i-handle. At yung process ng pag-convert ng continuous data attribute values into a finite set of intervals with a minimal loss of information na na-discuss kanina.